Hi Navneet. Hi Sriharini. Good morning.
Hi, ma'am. Good morning, ma'am. Good morning,
Morning.
ma'am.
Good morning. So now this is block 10. Cite some property of triangles. Lesson 1. Cite some property of triangles. Okay, so we'll understand this triangle. I'm sorry, we'll understand this property about triangles. Now, supposing we have the lengths of three sides like this, 4 centimeters, 5 centimeters, and 8 centimeters. Now we know a triangle has three sides, right? So a triangle has three sides. If you call this triangle ABC, we are trying to check if AB can be 4 centimeters, BC 5 centimeters, and AC 8 centimeters. We're trying to understand if we can form a triangle using these line segments. We have the lengths of three line segments here, 4 centimeters, 5 centimeters, and 8 centimeters. Now we are trying to understand if these three line segments can form a triangle. So you can see here triangle ABC. We're trying to understand if AB can be 4 centimeters, BC 5, and AC 8 centimeters. All right. So now for that, let's add two sides of the triangle. And when you find the sum, it should always be greater than the third side. When you find the sum of any two sides of a triangle, it should always be greater than the third side. So let's check that. 4 plus 5. What is the answer? What is 4 plus 5? 9. Is it greater than the yeah? Is it greater than the third side? 8? Yes, true. See, this is the first side. Second, you can take it in any order. Any order. Not that you should take 4 only as the first side. You can mark the first, second, and third sides in any order. So supposing we take 4 centimeters as the first side, 5 is the second side, and 8 as the third side. Now the first side plus the second side, 4 plus 5, it's 9. And is 9 greater than the third side 8? Yeah, 9 is greater than the third side. The sum 9 is greater than the third side 8. True. Now the second side plus the third side. The sum is 13. And is it greater than the first side? 4? Yeah, yes, true. Yeah. The second side plus the third side, 5 plus 8. The sum is 13. And yeah, it is greater than the first side, 4 centimeters. So we finished, we found the sum of the first side and the second side and the third side. Now the third side and the first side. The third side and the first side. So you can write 4 plus 8 or 8 plus 4 is 12. So the sum of the third side and the first side is 12. And that should be greater than the second side. It should be greater than the second side. Yeah, 12 is greater than 5. So it's true in all the three cases. These are the three cases you can work. And you must get a true everywhere. If you get a true everywhere, then a triangle can be formed with these three line segments. If even one of this is false, of these three, even if one of it is false, then a triangle cannot be formed using these three line segments. That is, a triangle cannot be constructed using these three line segments. And you'll have to check all the three. Supposing you check the first one and it's true, you cannot stop there and say that yes, a triangle can be formed. You need to check all the three. And in all the three cases, the answer must be a true. Even if one of this is false, the conclusion is a triangle cannot be formed with the given three line segments. Okay, so the property is the side sum property. Side sum, don't write anything now. Side sum property in triangles. So this is the property. The sum of any two sides of a triangle is always greater than the third side. Is always greater than the third side. When you add any two sides of a triangle, it should always be greater than it will always be greater than the third side. If it is a triangle, then the sum of any two sides will always be greater than the third side. So this is the side sum property in triangles. We have something called the angle sum property, right? We've seen this earlier. Angle sum property is when we add the measures of the three angles of the triangle. The total is 180 degrees. The sum of the three angles in a triangle is 180 degrees. So that is angle sum property in a triangle. This is the side sum property. The sum of any two sides of a triangle is always greater than the third side. Got this? Harini and Navneet?
Yes, ma'am. Yes, ma'am.
Okay. Now, let's check if these three line segments can form a triangle. Okay, so we have three line segments here, 5 centimeters, 7 centimeters, and 15 centimeters. Now, without constructing, we want to check if these three line segments can form a triangle or not. Okay. So the sum of the first two sides, or the sum of the first two line segments, 5 plus 7 is 12. And is 12 greater than 15? Is it true or false?
False, ma'am.
False. Now you don't have to check the others because it's a false. Even if one is a false, a triangle cannot be formed. But we'll just work the others. What is 7 plus 15? 22. And it's greater than 5. True. And 15 plus 5 is 20. And it's greater than 7. True. It's true in two cases, but false in one. So what is the conclusion? Can a triangle be formed with these three line segments? Yeah, you must be quick to answer. Yeah, Harini?
No, ma'am.
No, a triangle cannot be formed. A triangle cannot be formed because the sum of 5 and 7 is 12. And this should be greater than the third line segment. 5 plus 7, when you add two line segments, the sum should be greater than the third one. 5 plus 7 is 12, and 12 is not greater than 15. So a triangle cannot be formed with these three line segments. A triangle cannot be constructed. If you try to construct a triangle with these measures, you will not be able to, construct the triangle. So I don't know if you have constructions of triangles, but it will be like, the arcs will not meet. When you try to cut the arcs, the arcs will not meet. Okay. Now, the other thing is there's another property. It's not mentioned in XSEED, but you can know this. The difference of any two sides of a triangle. The difference of any two sides of a triangle is always less than the third side. Is always less than the third side. The difference of any two sides of a triangle is always less than the third side. The sum of any two sides of a triangle is always greater than the third side. The difference of any two sides of a triangle is always less than the third side. Okay. So let's check for the same line segments 4, 5, and 8. We got a true here, right? 4, 5, 8. Let's try that using this property. 4, 5, and 8. So the difference of any two sides of a triangle. So you should take the line segments in the correct order. Don't find 4 minus 5. Don't get a negative difference. Don't subtract, to get a negative difference. So take it as 5 minus 4. 5 minus 4 is 1. The difference of two sides. This is the first side, this is the second side. Don't write 4. You can add 4. 4 and 5 is 9. But 4 minus 5 is minus 1. So don't subtract in that order. Second side minus the first side. Anyways, we have taken the first two sides. We have taken the first two sides. Their difference, 5 minus 4, is 1. And this should be less than the third side. Less than the third side. Yeah, 1 is less than 8. True. Then take the second and the third side. Take two sides at a time and find their difference. Now take the second and the third side. The second and the third side. So 5 and 8. Don't find 5 minus 8. Find 8 minus 5. Anyways, you're taking the second and the third side. So 8 minus 5. The difference is 3. The difference of two sides should be less than the third side. So less than, which is the third side here. So this, see, 5 and we have taken the sides 5 and 8. So when you take 5 and 8, the left out side is 4, right? So 3 is less than 4. True. Now tell me, Harini, what's the last one we have to check?
Ma'am, 8 minus 4, ma'am.
Yeah, what is 8 minus 4?
4, ma'am.
4. And it's completed, yeah.
5 is greater than 4, ma'am. So 2, ma'am.
Okay, no, but we should use a less than symbol here. So 4 and 4 is less than 5. You're right. You're correct. 8 minus 4 is 4 and 4 is less than 5. This is true. So it's a true everywhere. So a triangle can be formed using these measures.
Ma'am, may I ask a question?
Sure.
Ma'am, is there any specific name of this property?
No. It's not called the difference side property or something. No, nothing.
Okay.
Yeah, nice question, but there's nothing like that.
Okay.
Yeah. Okay, now using these two properties, you can find now when you're given the lengths of two line segments, using this property, you can find the range of the length of the third line segment so that these three form a triangle. We'll take an example to understand this. Now, supposing you're given two line segments, 6 centimeters and say 10 centimeters. Now, your question is to find the range of the length of the third side. Range meaning that the length of the third side can lie between, say, for example, between 12 centimeters and 20 centimeters. The range, meaning the length of the third side can lie between 12 centimeters and 20 centimeters. You need to give an answer like that. We're given the length of two line segments, 6 centimeters and 10 centimeters. The question is, what are the possible lengths of the third line segment so that these three can form a triangle? So for that, there are many answers. That is why the question will be find the range. All right. So for that, you need to use these two properties. We are given 6 centimeters and 10 centimeters. What can be the possible lengths of the third side so that these three sides can form a triangle? So that these three line segments can form a triangle. Okay. So what is the sum of the two sides given? 6 plus 10. We'll find the difference first. 1 minute. We'll first find the difference. Okay, first find the difference of the two sides given. First find the difference of the two sides given. So 10 minus 6, 4. Find the sum of the two sides given. All right. So now the answer is the third side. The third side can be greater than 4 centimeters, but less than 16 centimeters. So the length, if with 6 and 10, if you need to take another line segment so that they can form a triangle, the length of the third line segment can be anything more than 4 centimeters, but less than 16 centimeters. It can be anything more than 4. So it can be 4.1, 4.2, 4.3, 4.25, whatever, anything more than 4. But less than 16. It can be 15.9, 15.8. Anything, it cannot be 4. It should not be 4. If it is 4, a triangle cannot be formed. If the length of the third line segment is 16, triangle cannot be formed. But it can be anything more than 4, but less than 16. It should be between 4 and 16. So the range is 4 to 16. What do you understand by range? You must you must fix a lowest value and a highest value. That's what is a range. Yeah. Range means you must fix or set a lowest value and highest value. So these are the boundaries. 4 centimeters, 16 centimeters. These are the borders. Anything between this can be the length of the third line segment. All right?
Yes, ma'am.
Yeah. Yeah. Yeah, Harini and Navneet, just give me 5 minutes. I'll just come back. In the meantime, you can try question number 3. Please try question number 3. All right?
Yes, ma'am.
Yeah. So this is about what we just discussed. Find the range of possible values of the third side of each triangle given the lengths of the other two sides. Exactly this. We just discussed that, right? Yeah, you can take a screenshot. If you want, you can take a picture of this. Take a picture. Yeah, now try the third one. I'll just come back in less than 10 minutes. Yeah, Harini and Navneet, I'm back.
Yes, ma'am.
Yeah. So children, I want to go ahead. We have a class today evening. So we'll see the answers. Now you would have worked this one, the answers to the questions in 3. We'll see the answers in the evening. All right. I'm going ahead now.
Okay, ma'am.
Yeah. All right. So next we are going to read about okay, next we're going to understand a very, very important property in a right triangle. Okay. So it's called the Pythagoras theorem. All right. Or it's also called the Pythagorean theorem. Pythagorean theorem. All right. So this is a very important property seen in a right triangle. Consider a right triangle PQR, right angled at Q. PQR is a right triangle, right angled at Q. Now, the sides containing the right angle are called the legs of the right triangle. So QR is a leg of this triangle PQR, and PQ is also a leg of this triangle PQR. PQR is a right angled triangle. The sides containing the right angle. These are the two sides containing the right angle. See, this side and this side, they contain the right angle. The sides containing the right angle, the sides containing the right angle are the arms of that angle, are the arms of the right angle. We know an angle has two arms, right? An angle has two arms. This angle, these are the two arms of this angle. So 90 degrees, this is one arm, this is the other arm. The arms of the angle or the arms of the right angle are called the legs in a right triangle. And this is called the hypotenuse. Hypotenuse. That is the side opposite to the right angle. The side opposite to the right angle is called the hypotenuse. So in a right triangle, the three sides have some special names, right? So the side opposite to the right angle, the side opposite to the right angle is called the hypotenuse, and the two sides containing the right angle, that is the sides which are the arms of the right angle, are called the legs of the right triangle. And in a right triangle, the hypotenuse is the longest side. The hypotenuse is the longest side. Now consider this triangle ABC. It's right angled here. The measure of this angle is 90 degrees. So ABC is a right triangle, right angled at A. ABC is a right triangle, right angled at A. So the side opposite to the right angle, BC, is the hypotenuse. Is the hypotenuse. the side opposite to the right angle. BC is the side. BC is the side opposite to angle A. That's the hypotenuse. And the right angle is contained by these two sides. These two sides are the arms of this right angle. Here, the right angle is here, and these two sides are the arms of the right angle, or these two sides contain the right angle. So they are called the legs. Each side is called a leg of the triangle. So AB is a leg, AB is a leg, AC is a leg, and BC is the hypotenuse. And BC will be the longest side. So these are the terms used for the sides in a right angled triangle. Two sides are called the legs, and one side is called the hypotenuse. The hypotenuse is the longest side in a right triangle, and it is the side opposite to the right angle. The two sides containing the right angle, the arms of the right angle, are called the legs of the right triangle. Now we also see these terms used in a right triangle: base, perpendicular, perpendicular, and hypotenuse. I'll just do it again, sorry. Perpendicular, base, hypotenuse. This base is a leg. This one is also a leg. So this is DEF. This triangle is called DEF, triangle DEF, right triangle. DEF, right angled at E. EF is the base, which is a leg. DE is the perpendicular, which is the other leg. And DF is the hypotenuse, because it is opposite of the right angle. Now, this is how the Pythagoras theorem goes. All right, the result by the Pythagoras theorem goes: the square on the hypotenuse. Okay, now let's write the squares of all the sides. Let's write all the three sides first. So DE, EF, DF. These are the three sides of this right triangle: DE, EF, DF. Now square square all the three sides: DE square, EF square, DF square. Now the result is DE square plus EF square is equal to DF square. I'll tell you the statement in words. We'll first understand how to write this equation given by Pythagoras theorem. Then I'll tell you the statement in words. We'll do this again. This theorem, the Pythagoras theorem or the Pythagorean theorem, holds good only for a right triangle, not for any triangle, only for a right triangle. Let's write the three sides of this triangle: DE, EF, DF. Square the three sides: DE square, EF square, DF square. Now the theorem goes like this: DE square plus EF square is equal to DF square. So what is DE? What is DE? It's the perpendicular. So perpendicular square plus what is EF? Base. Base square is equal to DF. Hypotenuse square. So this is the result by Pythagoras theorem. Perpendicular square plus base square is equal to hypotenuse square. Or you can write base square. You can also write base square. Base square plus perpendicular square is equal to hypotenuse square. So what you should remember is hypotenuse square will be alone on one side. Hypotenuse square will not come with any other squares. So base square plus perpendicular square is equal to hypotenuse square, or perpendicular square plus base square is equal to hypotenuse square. 1 minute, children. 1 minute. So base square plus perpendicular square is equal to hypotenuse square, or perpendicular square plus base square is equal to hypotenuse square. So hypotenuse square stands alone on one side, and base square and perpendicular square added on the other side. You can also write like this. Hypotenuse square is equal to, you can also write it like this. Hypotenuse square is equal to base square plus perpendicular square. This is also correct. So if I name the sides like this, A, B, and C, A square plus B square is equal to C square, or C square is equal to A square plus B square. See, you can see it's a right triangle. The three sides are marked A, B, and C. Clearly, C is the hypotenuse because it's opposite of the right angle. C is the hypotenuse. So you must square that and write it separately on one side. It will not come with any other. So the result by Pythagorean theorem is A square plus B square is equal to C square, or C square is equal to A square plus B square. See here. Right triangle. If this is called X, this is called Y, and this is called Z. Now this is the right angle. So opposite of the right angle, this is the hypotenuse. This is the hypotenuse. These are the legs. Hypotenuse, these are the legs. So you can take one side as the base, the other side as the perpendicular. Any base and perpendicular can be exchanged. Don't worry about that. Base and perpendicular are the legs basically. They are the legs. So the result is x square plus z square is equal to y square. Remember that hypotenuse square will be alone on one side. X square plus z square is equal to y square, or you can write y square is equal to x square plus z square. Now, Harni, tell me for this one. Yeah. Complete. I'll just start. Mn square. Mn square, Harini.
Mn square plus Pn square is equal to Pm.
Very good. You can write Pm or MP. Both are the same. Pm square. Very good, Harini. Navneet.
Yes, sir.
Yeah, tell me, Navneet. Apply Pythagoras theorem in this triangle.
Ma'am, C square plus E square is equal to D square.
Very good. Understood, both of you?
Yes, ma'am.
Very good. Very good. So this is the result by Pythagoras theorem or Pythagorean theorem. Now let's see the statement. In a right triangle, the square of the hypotenuse, is equal to the sum of the squares of the other two sides. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This is clear, right? The statement?
Yes, ma'am.
Yes, ma'am.
Yeah. So see here, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So you can also write, see here, in a right triangle, the square of the hypotenuse, so PM square, the square of the hypotenuse, PM square, is equal to the sum of the squares of the other two sides. Which are the other two sides? Pn and Mn. The other two sides are Pn and Mn. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So this is the result by Pythagoras theorem or Pythagorean theorem. This is the statement. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So in general, it's called base square plus perpendicular square is equal to hypotenuse square. Any questions, children, so far?
No, ma'am.
All right, children. So that's it for today's session. Thank you so much. Harni and Navneet, you may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children.